I am Dr. Hepsi Pramila Devamani, Assistant Professor of Physics, V.V. Vanniya Perumal College for Women, Virudhunagar. We are going to see the architecture of 8085 microprocessor. This diagram shows the architecture of 8085 microprocessor. And this one consists of ALU, that is Arithmetic Logic Unit, Timing and Control Unit, General Purpose Registers, Program Status Word, Program Counter, Stack Pointer, Instruction Register and Decoder, Interrupt Control, Serial I/O Control, Address Bus and Data Bus. We are going to see one by one. The first one is Arithmetic Logic Unit. Arithmetic Logic Unit means this unit performs arithmetic and logical functions. Arithmetic functions means arithmetic operations are addition, subtraction, multiplication and division. Logical operations are AND, OR, NOT, XOR, XNOR, NAND and NOR operations. All these operations are done only in this arithmetic logic unit. The second one is timing and control unit. Every instruction can be executed only in a particular time. That time can be controlled by the clock signals. So the timing unit will provide the clock signals for measuring the time for executing any instruction. The control signals are read bar, write bar, ALE and IO bar, M bar signal. These are control signals. They are used to control the execution of the instructions. The next one is general purpose registers. This diagram shows the register array. In 8085 microprocessor, we are having the register. The first register is the accumulator. It is an important register. Through this register only any arithmetic and logical operations can be performed. And the remaining registers are B, C, D, E, H and L. All these are 8-bit registers. We can also use the combination of B, C, D, E and HL as register pairs, where there is a necessity of storing 16-bit data. And the next one is program counter. This program counter, it is nothing but the memory pointer which points the instruction to be executed next. Stack pointer is also a 16-bit memory pointer which indicates the starting address of the stack. Stack means it is nothing but the group of memory locations. It is used to store the temporary address in that particular location during the execution of the instruction. The next one is program status word. In this program status word, it is nothing but the combination of the registers accumulator as well as the flag register. Both can be used as a 16-bit register pair. It is known as program status word. Then program counter, it is nothing but the memory pointer which indicates the instruction to be executed next. Similarly, stack pointer is also a memory pointer which indicates the starting address of the stack. And the next one is instruction register. This register is used to store the instruction in the program one by one. And the decoder, it is used to decode the instructions. That is, it is used to decode the instruction into machine language. The next one is interrupt control. Interrupt control means in 8085 microprocessor, there are 5 interrupt signals: trap signal, RST 7.5, RST 6.5, RST 5.5 and INTR. Among the 5 interrupt signals, trap signal is the non-maskable interrupt. That means when this interrupt comes to the microprocessor, it has to stop its execution, whatever may be the thing, then it has to attend the trap signal. And the remaining interrupt signal RST 7.5, 6.5, 5.5, these are maskable interrupts. That is, the microprocessor can do its work, and after completing its work, it can attend the interrupts RST 7.5, 6.5 and 5.5. Among the 5 interrupts, trap signal and RST 7.5, 6.5 and 5.5, they are known as vectored interrupts. That means for each interrupt signal, there is a interrupt service routine. That is, for each interrupt signal, there will be, the control will be transferred to some particular memory location. That will be given by the microprocessor. It is a inbuilt function. But on the last interrupt, that is INTR, it is a non-vectored interrupt. That is, there is no particular interrupt service routine for this INTR signal. And when you use this INTR signal, the IO device must send the interrupt request signal to the microprocessor, and the microprocessor will give the acknowledgement signal, that is INTA bar signal. It is an active low signal. So this signal is an acknowledgement signal given by the microprocessor to the IO device. Then flag registers. Flag register means there are 5 flag registers in 8085 microprocessor. They are carry flag, parity flag, auxiliary carry flag, zero flag and sign flag. They are used to test any condition in between the program. Carry means it is nothing but the overflow. That is, when you add 2 binary numbers, if the binary numbers are of 8 bit, the resultant number, if it contains 9th bit, that is known as carry or overflow. So if in doing this any arithmetic operation, if there is a carry, then the carry flag will set. If there is no carry, the carry flag will be reset. The next one is parity flag. In the given binary number, if the number of ones is equal to an odd number, that is an odd parity number. If the number of 1 is equal to an even number, then it is an even parity number. So if the given data contains even number of ones in the number, then the parity flag will set. Otherwise, it will be reset. Then auxiliary carry means it is nothing but the intermediate carry. That is, in between the 2 nibble, we are having 8-bit number. The 8-bit binary number can be divided into 2 nibbles. So the carry from one nibble to the other nibble, that is known as auxiliary carry. So when there is auxiliary carry, this auxiliary carry flag will be set, but this cannot be used by the user in writing the program. Then zero flag. So when we are using in doing any calculation, suppose if you are going to compare 2 numbers, then you have to subtract the 2 numbers. The result may be 0, or it may be plus, or it may be minus. If the result is 0, then the 2 numbers are equal. So when the result of any operation is 0, then the 0 flag will set, otherwise it will be reset. Then last one is a sign flag. Sign flag means it is nothing but the flag register which is used to represent whether the data is a negative number or a positive number. The sign flag will set when the data is a negative number. If it is a positive number, the sign flag will be reset. And here the W and Z register, they are the temporary registers and they cannot be used by the users. And in the time control unit, we are having 4 signals: read bar signal, write bar signal, ALA signal, and as well as the IO bar M bar signal. Read bar signal and write bar signal, they are the active low signals. That means when we are giving the 0 to that particular signal, then only it will be active. And this read bar signal is used to read the data from the input device to the memory. And write bar signal, it is used to write the data. After doing some calculation, the output should be displayed. So the data from the memory can be written on the output device. That is, for that purpose we are using this write bar signal. And this ALE signal, here we are in microprocessor, we are having address bus as well as a data bus. Address bus means it is nothing but a line which is carrying a information. So for address we need 16 bit. So we need for address bus 16 lines. So but microprocessor 8085 microprocessor, it is a 8-bit microprocessor, but the address bit, it is 16-bit process, the 16-bit data. So you have to divide the 16-bit into 2 parts. The first half is known as lower order address. The second half is known as higher order address. So in order to send the address through the bus, that is, we are needing the address bus. We need 16 lines, that is known as address bus, and the address bus, it is a unidirectional one. And another one is data bus. The data can be sent through the 8 data lines. The data bus, it is a bidirectional, that is, we can able to read as well as write the data. So when in the case of 8085 microprocessor, we are having the lines AD0 to AD7. That is, A represents address, D represents data. So through this AD0 to AD7 lines, we can able to send both address as well as data. So it is known as multiplexing. At first, the lines are used to send the address. So in order to find whether the information sent through this AD0 to AD7 or address or data, you have to use this ALE signal. ALE means address latch enable. When this address latch enable signal is high, it represents the information in the lines AD0 to AD7 represent the address. Then after some time, the same lines can be used for sending the data. At that time, this address latch enabled, that is ALE signal must be low. So this is also a control signal. Then another control signal is a IO bar M bar signal. Here this IO bar M bar represents whether the operation is related to memory or it is related to IO. So when this IO bar M bar signal is high, it is related to IO. IO means input output device. When the IO bar M bar signal is low, it represents the operation is related to the memory. Since we are having M bar, it is an active low signal. So when we are giving 0 to this IO bar M bar signal, it represents memory operation. When we give 1 to this IO bar M bar signal, it is related to the IO operation. Then instruction decoder and machine cycle encoder. This instruction decoder, it is used to decode the instruction. That is, we are writing the program in the microprocessor using hex code. That hex code will be converted into machine code. For this decoding purpose, this instruction decoder register is used. And also this machine cycle encoder means the machine code is the hex code is converted into machine code, and that will be understood by the 8085 microprocessor.